In this section, we're going to talk about the difference between simple interest and compound interest. And the formula that we're going to be using for compound interest requires you to be comfortable with exponents. So I'm going to go through just some basics on the exponent rules so you can understand how exponents work and then feel more comfortable when you're punching this in on your calculator. So just a quick review on powers. Okay, we have the product rule, and the product rule just states if you have two bases and you're multiplying them together and they have exponents, we'll call them n and m. So you have the same base, we'll call it b for base. You're multiplying two factors with exponents n and m. When you multiply and your bases are the same, you want to add your exponents together. So my answer would be b to the power of whatever n plus m is. So for example, if I take 2 to the 5th times 2 to the 3rd, my base stays the same, so I'm going to answer it as 2 to the power of, and then I add my exponents. 5 plus 3, that gives me 8. Now this works as long as your bases are the same. If I have two different bases, such as 2 to the 5th times 3 to the 3rd, I can't use this rule. My bases have to be the same. For the quotient rule, it's very similar. If I have b to the power of n and I divide by b to the power of m, the rule is I keep my base the same, but I subtract my exponents now. So I have n minus m. So for example, if I had 2 to the 8th divided by 2 to the 5th, my base stays the same and I subtract my exponents. I take the top exponent minus the bottom exponent. So I take 8 minus 5, which would give me 3. 2 to the 3rd means 2 times 2 times 2, which would give me 8. This one's a little bit harder up here, 2 to the 8th, just because it's going to be a really big number. I'll just leave it as 2 to the 8th. The power rule is when you raise an exponent to a power. So for example, if I have b to the power of n, and I want to raise that whole thing to the power of m, what I do is I multiply my exponents. So my base stays the same, but I multiply n times m. So for example, if I had 2 to the 3rd, and I want to raise that to the 5th power, my base stays the same, and I multiply 3 and 5, so I get 15. Okay, for negative exponents, I have b to the negative n. The negative exponent just tells me to take the reciprocal. So since, even though I don't write it in there, this is b over 1, even though I don't write it in there, this is b to the minus n. It's the same thing. That just tells me to take the reciprocal, and then the negative goes away. So I would say 1 over b to the power of n, which is also another way to say that is 1 over b to the n. So for example, if I wrote down, like say 2 to the negative 5th, even though I don't write it in there, this is 2 over 1. Okay, I'm going to take the reciprocal, and I'm going to raise it to the positive 5, because I took the reciprocal, which I can rewrite that as 2 to the 5th in the denominator, 1 over 2 to the 5th, and 2 to the 5th is 32, so I can write it as 1 over 32. For zero exponents, what you have to keep in mind is this rule only works if the base is not 0. It can be anything but 0. If you take anything and raise it to the 0 power except for 0, b cannot be 0, that gives me 1. It seems a little strange and anti-intuitive, but I'm going to show you why here. Just to keep in mind, the base cannot be 0. I can't take 0 to the 0. This is undefined. Here's why when you raise something to the 0 power, it's equal to 1. If I give you, let's say 2 to the 3rd over 2 to the 3rd. I know using my experience with fractions, when the top and the bottom are exactly the same, it's equal to 1. Because I have the same thing on the top and the bottom, and I'm just dividing it, and I get 1, just like 4 divided by 4 is 1, 5 divided by 5 is 1, 100 divided by 100 is 1. If the top and the bottom are the same, the fraction is equal to 1. But now, if I look at it from a different perspective, if I use my quotient rule, if I scroll back up here, my quotient rule says if my base is the same, I subtract my exponents. So I take the top minus the bottom. So here, look, my base is the same, and if I take the top minus the bottom, I get 0. So 2 to the 0 is equal to 1. Okay, and then the last example is if you have exponents that are fractions. So if I have, for example, a base b and I raise it to the power of n over m, that is the same thing as saying the m root of b to the power of n, or another way you can write it is the m root of b and then everything raised to the n power. You can say it either way. So remember that the bottom is always going to be your root, and the top will be your exponent. So that's my top, that's my exponent, and then the bottom, which is my root. So square root, cubed root, something like that. Okay, so an example of this would be, I'm going to give you 2 examples since you might not be as comfortable with this. If I give you the first example, 16 to the power of 1/2. Remember, the bottom number in the fractional exponent means the root. So this says I'm going to take the square root of 16 to the first power. The square root of 16 is 4, and then when I raise 4 to the first power. Another example is if I have 32 to the power of 3/5. So remember, the bottom number in the fraction that's in the exponent is the root. So I want to take the 5th root of 32. And then once I get that answer, I'm going to raise it to the 3rd power. The 5th root of 32 is 2. And then I raise 2 to the 3rd, that gives me 8. To do fractions on your calculator, you can use, there's several different buttons, but I like to just stick with this button right here that looks like a little arrow looking up. So if I want to raise something to a negative exponent, let's look at the example I did up here for negative exponents. Let's see. Let's look at this example right here. I want to take 2 and raise it to the power of -5, and I want to show that that's 1 over 32. So I'm going to take 2, and I'm going to raise it to the power of, and then in parentheses, I'm going to put -5. Now, some of you guys might have the newer model where it actually raises it up on your screen so that you can see that the negative's in the exponent with the 5. But if you don't have that newer model, you want to definitely make sure you put parentheses around your exponent. That way the calculator knows the negative is included in your exponent. When I hit enter, of course, it's going to give it to me in decimal form, but I can check by working backwards and tell it to put it in fraction form to show that it's 1 over 32. Okay, let's do 0 exponents. Let's say I want to raise 2 to the power of 0, and I'm going to get 1. Okay, now if I dig 0 to the 0 power, we know that's undefined. Let's check, see what the calculator does. It'll probably give us some kind of error. Yeah, it's going to give us an error message because it's undefined. Okay, now let's do a fractional exponent. I want to take 32 and raise it to the power of 3/5. That's this example right here. So I'm going to take 32 and I want to raise it to the power, and then I'm going to do 3/5. If you don't have the newer model where you can see that the entire 3/5 fraction is raised up in the exponent, then make sure you put parentheses around it so the calculator knows that you're doing 3/5 in the exponent and not just 32 to the third power and then take that whole answer and divide it by 5. You have to make sure you use parentheses correctly. Okay, so I'm going to hit enter and it gives me 8. Okay, so now that we had some review on exponents, we'll be a little bit more comfortable when we are working with our compound interest formula. I think some terminology that we need to go over first is what the principal is, and the principal is the starting balance when you put money into a bank or you invest some money or maybe it's on a loan, okay? It's your starting amount that's used to calculate your interest. Then there's a difference between what's called simple interest and compound interest. Simple interest is paid only on the original amount of the investment. So the difference would be when we talk about compound interest, when we calculate interest and we add that interest back into the account, and then the next month or the next quarter or however many times we calculate the interest, when we go to recalculate that interest, if it includes the interest from before plus the principal amount, that's when it's compounding. And then again, I want to stress the simple interest is only interest calculated on the original investment. Okay, so here's our information for our formula. Okay, so A is the accumulated balance. So what we mean by the accumulated balance is if I started off with $100 in my bank account and I got some interest, and at the end of the month, I made $5 in interest. So my accumulated amount would be $105 because it's the principal plus the interest that was earned. That's the accumulated amount. P is your principal in the formula. APR is your annual percentage rate, but when we put it in the formula, we've got to make sure we remember to put it as a decimal. So for example, if the interest rate is 5%, when we put it in the formula, we want to make sure we put it in as 0.05 as a decimal. Little n is the number of compounding periods per year. So what that means is the number of times we recalculate the interest and add the interest back into the balance. So for example, if it was compounded monthly, like most banks look at your interest monthly, they calculate the interest and they add the money back in. If it's compounded monthly, that means little n would be 12 because it's the number of times it's compounded per year. Now, there is a difference between big N and little n, so what I want to do is I want to correct this. This should be a little n. I think that's a little confusing. When we talk about big N, that is the total number of times compounded over the entire loan period. Little n is how many times it's compounded per year. Big N is the number of times it's compounded throughout the entire time that you have your money invested. Okay, and Y is the number of years. So going through these variables, that hopefully helps you understand what they mean. When we start going through some examples, it will click and it will make a little bit more sense. But before we do that, I want to just go through a few more things that you need to know about this formula. So I want to make a chart with you to help you kind of visualize the difference between little n and big N. let's say we'll use for this example, we're going to say this is over a period of 5 years. Okay, if the problem states that it's compounded annually, that means it's compounded one time a year. So that means little n is 1. Little n represents the number of times it's compounded per year. Big N is the number of times it's compounded over the entire time that you have this investment. So if we have this investment for 5 years and is compounded one time a year, then that means total is compounded 5 times. So big N would be 5. If the problem says it's compounded semi-annually, that means it's compounded twice a year. So keep in mind, please, this means the number of times per year, where big N is the total number of times it's compounded. So if it's twice a year for 5 years, that means big N would be 10. It's compounded 10 times over the entire time that it's the entire time of the investment. If it says it's quarterly, if it's compounded quarterly, that means it's 4 times a year. And over 5 years, 4 times a year for 5 years, that big N would be 20. And the last one that you'll probably encounter is daily. Now, I know we have leap years and everything to worry about, but we're just going to assume that there's 365 days in a year, and we're not going to worry about the 1/4. So if it's daily, we're going to say it's 365 times a year. And then the big N would be, if it's 365 for 5 years, that would be 365 times 5, which would be 1,825 times. So hopefully looking through this chart, you can see the difference between little n and big N, because that's really going to come into play later, that you need to know the difference of those. Okay, so this first example, I want to go through so you can see the difference between simple interest and compound interest. Okay, remember, simple interest is only calculated on the starting balance. Okay, compound interest, when you calculate the interest, you're including the accumulated balance. So in this problem, it says you invest $100 in 2 accounts that each pays interest at a rate of 10%. But one pays simple interest and the other pays compound interest. We're going to make a table to show the growth of each account over a 5-year period. And then we're going to use our compound interest formula for the first time to verify our answer. We're going to do it all in one step versus figuring it out for each year. Okay, now here are the key words that we're looking for. It's an interest rate, 10% per year. And we're doing this for 5 years. Okay, so we're going to start with the simple interest. If I have 100, I'm starting with, and I want to find 10% interest. I want to take 10% of 100, so that means 100 times 0.10. That's going to give me $10. So my balance is now going to be $110 because I started with 100. I made $10 in interest. Okay, now in year 2, I just repeat. I'm taking 10% of 100 because I only calculate, with simple interest, I only calculate it on the principal. I just made $10 in interest on the second year. So now I have $120. Okay, and we go through and repeat this process. For year 3, I calculate my interest. That's going to be $10. So on the third year, I'm going to have $130. Year 4, same thing, repeat the pattern. I'm going to get $10 in interest, so now I have $140. And then my last year, I do it one more time. I make one more $10. And then, let's see, that gives me $150 total after 5 years. So I made $50 in interest over the 5 years with simple interest. Okay, now let's go back up and do the same thing for compound interest. And this is where you're going to start to see the difference. Okay, so compound interest, when we calculate the interest, we're calculating it on the previous interest and the principal. So if I start off with the $100 and I find 10% of $100, my first year, I have $110. So my first year, I made $10 in interest. But when we do compound interest and I go to year 2, I am finding the interest based on the accumulated amount, not just the principal. So now I'm going to take 10% of $110, which is going to give me $11. So now my balance is going to be $121. On the third year, I take 121, which is my accumulated balance so far, find 10% of that, and I'm going to get $12.10. When I add it up to find my accumulated balance, I have $133.10. Okay, year 4, I'm using my accumulated balance to find the interest. When I take 133.10 times 0.10 to find my interest, I'm going to get $13.31. So I add that to my previous balance, and my new accumulated balance is 146.41. Okay, and for my last year, I'm going to take 146.41 and multiply it by 10%. Find my 10% interest. I'm going to get 14.641, but since we're talking about dollars and cents, let's round it to $14.64. And when I add that to my accumulated previous balance, my final accumulated balance for the 5 years would be $161.05. So the interest I earned for the compound interest would be $61.05. So hopefully that illustrates the difference between the simple interest and compound interest. Now, let's go through and use the formula to check our final answer. So this will be the first time we're using our formula, and we can kind of compare doing it by hand each year or each compound period in general versus just plugging it into a formula. So our compound formula is A for our accumulated amount, and then is equal to my principal times 1 plus my APR, which is my annual percentage rate, divided by N, which is the number of times it's compounded per year. And that's all raised to the power of N times Y. That's the number of times compounded per year times the number of years. So when I plug in all my information, P is my principal, so I started with $100. 1 plus, now my APR is 10%, but remember when I put it into the formula, I want to put it in as a decimal, so 0.10. This was compounded annually, once a year, so I'm going to divide by N is 1. And then N times Y would be 5, because that's the number of times compounded per year times the number of years, which is 5. So we can put that in our calculator. So I'm going to do, let's turn this on, 100, and then in parentheses, I'm going to put 1 plus 0.10 divided by 1, close parentheses, and I want to raise that to the 1 times 5 power. Make sure I put my exponent in parentheses also if I don't have that newer model calculator that shows that the whole thing is in the exponent. When I hit enter, I get my accumulated balance, which is 161.05, which is what we got when we did it by hand. But with the formula, it's much nicer because you can do it all in one step. So this one was easy to do by hand because it was only compounded 5 times once a year for 5 years. But if we try to do that by hand over 30 years monthly, that would be 360 times it's compounded, and that would be 360 computations. So it's much easier to use your formula. In the next example, we have your grandfather put $100 under his mattress 50 years ago. If he had instead invested it in a bank account paying 3.5% interest compounded yearly, how much would it be worth now? So let's find the accumulated amount that he would have if he put this in the bank under these conditions. So he started with $100, so that's our principal. The APR is 3.5%, so when I put that in decimal form, that's going to be 0.035. And I got to divide that by my little n. Now, like I said, this is compounded yearly, so little n would be 1 once a year. And then this is once a year for 50 years. So 50 is going to go here. 1 times 50, which is just 50. Okay, when we put that in the calculator, see, we get an accumulated amount of $558.50. So this is the accumulated amount. This is the $100 plus the interest. So the interest he would have earned would have been $458.50 if he put it in the bank rather than stuff it under a mattress. You deposit $5,000 in a bank account that pays APR of 3%, and it compounds the interest monthly. We're going to figure out how much we would have after 5 years. And then we're also going to do the same thing, but we're going to do it if we compounded it yearly, and we're going to compare. So let's do monthly over here, and we'll do yearly here. Okay, so our principal, our starting amount is $5,000, so that's going to go in for our P in our formula. And let's see, we have 1 plus, and then our APR is 3%, so when I put that in, I want to put it in as 0.03. And if it's monthly, that means little n is 12. It's compounded 12 times a year. And then in my exponent, I want to put n times the number of years. So that's 12 times 5. So big N would be 60. It's compounded 60 times in total. Okay, when we put this in on the calculator, we get $5,808.08. So that's the accumulated balance. So it's $5,000 plus the interest. So the interest that was earned is $808.08. Now for yearly, we're going to use the same thing, but little n is going to be 1 now. If it's compounded 1 time a year, n is going to be 1. So I have 5,000. 1 plus 0.03 divided by 1. And then I raise that to 1. Whoops. And I raise that to the power of 1 times 5. When I put that in on the calculator, I get an accumulated amount of $5,796.37. So that means the interest that was earned over the 5-year period, since we started with 5,000 and ended up with 5,796.37, our interest earned was 796.37. Okay, now that I showed you how to use the formula by hand, I want to show you an app that you have on your calculator that you can use to make sure you got the right answer. So what you want to do is you want to hit the button. It's 2 buttons above your comma. It says apps. Hit the apps button. And then the first option should say finance. We're going to choose finance and hit enter. And then we're going to choose TVM solver. That's time value money. And I'm going to hit enter. And then what we're going to do is we're going to enter all this information, and then the calculator is going to spit out the answer for us, and we can check it against what we did by hand with the formulas. So remember, I made a big deal about understanding the difference between little n and big N, and it's because if you use your calculator app to check your answer, you have to understand the difference, because the calculator uses big N, which is the total number of times it's compounded. Okay, then you have I, and on the calculator it says I%, that's your APR. And then PV stands for present value. And that's what you want to think of as your starting value. PMT is payment. So we're not going to use that quite yet, because what we're talking about in this section is lump sums of money, where I just throw a bunch of money in a bank and I stand back and I watch it grow. I'm not talking about adding in more money and making payments into the bank like I would if I were depositing my monthly paycheck. Okay, so in this section where we're only talking about compound interest, we're not talking about making payments, we're going to use the payment option as 0 right now. The FV stands for your future value. That's your accumulated amount. How much are you going to have later? And the PY and the CY, that just represents the number of times it's compounded per year. So that's your little n, is the PY and the CY. And then where it says at the bottom payment end and begin, make sure it's highlighted on end. We're not going to do anything with the beginning. That's a whole nother class. Okay, so I want to check my answers that I just did in this previous example when I deposit $5,000 into a bank account. So what I'm going to do is I'm going to scroll down. $5,000 is my principal. That's what I'm starting with. So I'm going to enter that in as my PV, my present value. So I'm going to put in $5,000. Okay. My interest rate, my APR, is 3%. So I'm going to go up to my I and make sure I put in 3. Now, the nice thing about the calculator app is that you don't have to change it to a decimal. If you notice, it has I% in there, so it wants you to actually put that in as the actual percentage. You don't need to change it to a decimal. Okay, now PMT, we're not making any payments, so leave that as 0. Future value is what we're solving, so leave that alone for now. My PY and my CY, if we do the monthly example first, my PY and my CY should be 12. It's compounded 12 times a year. Okay, so then I'm going to come up here and put in my big N. Since this is monthly for 5 years, my big N is going to be 60. It's compounded 60 times. Now, I can either put in 12 times 5, and the calculator will enter that for me as 60, or I can just put in 60 directly. Okay, once I have all my values entered except for what I'm trying to solve for, then I'm going to scroll down to whatever I'm trying to solve for. In this case, I'm trying to find my accumulated amount. Calculator language is future value. So I'm going to make sure my cursor is on blinking on the future value. And then what I'm going to do, right above my enter button, on this one it's green. I don't know if yours is in a different color. But right above the enter button, and this one is green, it says solve. And then I'm going to hit the green button here for alpha and enter. So I use the solve button. And it tells me what that amount is. $5,808.08. Don't worry too much about the negative. That just means the flow of money. So present value is I invested $5,000. Negative means it's coming in the other direction, means I'm getting back $5,808. So the negatives and positives just indicate which way the direction's flowing or the money's flowing. Okay, now let's do the same thing and we'll check our answer for yearly. Yearly means my big N is going to change. Whoops. My big N now is going to be 5. If it's yearly for 5 years, I'm going to have a total of 5 times that I'm compounding. Okay. Now, my interest is still the same. I'm still using 3%. I still have a present value of 5,000. That's still what I'm starting with. I still have a payment of 0. I'm not making any payments. Future value is what I'm looking for, so I'm going to leave that alone for right now. And then this is going to be yearly, so I want to change my PY and my CY to just 1 because it's once a year. Then I go up to my future value. That's what I'm looking for once I have everything in. And I'm going to use my alpha button and I'm going to hit my enter button to use the solve option. And it's going to tell me $5,796.37. So when you're doing this on a test or on your project, I want to see your formula done out, but you can use the calculator to check your answer. Okay, now let's talk about the annual percentage yield. This is different from the APR. And what happens is if we're using compound interest, in 1 year, money can grow more than actually the percentage that we have for the yearly percentage, the APR. Because every time we recalculate the interest when that's compounded, we're including the accumulated interest into that amount. So by the time we get to the end of the year, we actually have a relative increase in percentage that's more than the APR. And so let me show you how this is calculated. So we're looking at the relative change in percentage over 1 year. So remember, when we talk about relative change, if we think back, relative change means we're going to take the new minus the old amount, divide by the old amount, and multiply by 100. Well, when we're talking about percentage, and we're talking about principals and accumulated values, the new amount is going to be the accumulated value that we've gotten for the year, minus the old would be the principal, what we started with, divided by the principal, that's the old amount, and then we multiply it by 100. And then an even easier to look at this, if I take the accumulated amount and we subtract the principal, what we're left with really is just the interest for that year. And then we divide it by the principal, multiply by 100 to change it into percent form. Okay, so let's go through an example to illustrate this. Okay, if you deposit $1,000 in an investment with an APR of 8%, we're going to find the annual percentage yield with monthly compounding and daily compounding. So we're going to do this for monthly and for daily. Okay, so the first thing we're going to do is we're going to find the monthly accumulated amount. So we're going to take 1,000 and we're going to do 1 plus, the APR is 0.08. This is monthly, so little n is going to be 12. And when we calculate the APY, we do it just for 1 year. We're comparing the interest for just 1 year. So it's going to be monthly for 1 year, so that's going to be 1 times 12. When I put that in the calculator, I'm going to get $1,082 and then 0.9995. but just to make things easier, let's round it up to $1,083. That is really close to 1,083. Okay, now, if I calculate the relative change in percentage from the beginning of the year to the end of the year, we started with 1,000, we ended with 1,083, and we said, if we look up here, when we looked at that, if I subtract the principal from the accumulated amount, the new versus the old, really I'm looking at just the interest for that 1 year. So the interest would be 83, and then I divide that by my principal, which is 1,000, then multiply by 100, so I change it into percent form, and what I get is 8.3%. So here's where you can see the difference. This is my APY versus my APR, which is 8%. We use the 8% to calculate the compound interest, but when we look at it over the whole year, we actually earned 8.3% because every time we compounded that interest, we added that interest back in, and so we were actually accumulating more over the long run. So the APY is typically going to be more than the APR. For daily, we're going to do the same thing. I'm going to take 1,000, 1 plus 0.08, but since it's daily, little n is going to be 365. So it's going to be compounded 365 times, and then I take 365 times 1 year. When I put that in on the calculator, I'm going to get $1,083.28. So my interest earned was $83.28, and if I divide that by my principal and multiply by 100, that will give me my APY. So my APY is going to be 8.328%. So when it's compounded daily, even though we use 8% to calculate the compound interest for each period, over the whole year, we actually earned a relative percentage of 8.328%. Okay, and the last formula that we're going to use in this section is a formula for compounding continuously. Now, typically we don't see this with banking, but we're going to actually use it later on in the semester, so I wanted to bring it up now while we're talking about compounding. And compounding continuously, it's hard to imagine, but think about we're recalculating the interest like every second, every half a second. It's always continuously updating. Okay, so the formula is different. We take, to find the accumulated value, you take your principal times e to the power of your APR times your y. Now, e on your calculator, I'll show you in just a second how you can get that. That's actually an irrational number, just like pi is 3.14 and it goes on forever, but we round it to 3.4. E is an irrational number that's 2.71828 and it keeps going on forever, but typically we round it to 2.7. Okay, so an example to illustrate continuous compounding says we're going to deposit $100 in an account with APR of 8% and is continuously compounding. As soon as I see continuous compounding, I know I need to use this formula, not the previous formula that we've been using. How much are we going to have after 10 years? So here's my formula. I have P times e to the power of APR times the number of years. So we're starting with $100, so that's my P. Then I have e to the power of APR. APR is 8%, so I put it in as 0.08. And then this is for 10 years, so I take 0.08 times 10. Okay, so to put that in on the calculator, I'm going to take, let's quit out of that. I'm going to take 100 And then your E button, if you look right next to your 4 button on the left, there's the natural log button that says ln. And then right above it, mine's in yellow, but yours might be in a different color. Right above the ln button, it says e to the power of x. That's the E button that you're going to use. So in order to access this, I have to hit my second button first, and then I hit the ln button. And then it says e to the power of, and then I'm going to put in 0.08 times 10. That's my APR times my number of years. I'm going to hit enter, and it will give me my answer, which is $222.55. So this is my accumulated amount, just like before. So I start with 100. I have an accumulated amount of $222.55, which means the interest that I earned was $122.55. Now, one thing about this that I also want to comment, when you're doing continuous compounding, for the continuous compounding, you have to use this formula, and you will not be able to check it on the calculator. The calculator app that we did before, the Time Value Money app, does not deal with continuously compounding. One of the last topics that we need to talk about in this section is being able to use that compound formula, but to be able to solve it for another variable other than the accumulated amount. So one of the things that we're going to talk about later is being able to work backwards. If I know how much I want to save for the future, but I want to know how much I need to put into the bank right now, and I want to know what my principal should be in order to accumulate that amount that I need in the future, that would be called a present value problem, because we're trying to figure out what I need right now to save a certain amount in the future, and in a sense that's working backwards. So in order to be able to use that formula and work backwards, we need to be comfortable with solving equations. So I want to do a quick review of solving equations, and then I'm going to show you how we can apply solving equations to our compound interest formula to solve for present value or any other variable. Okay, so a quick review of solving equations. When I want to solve for x, I want to isolate x. So I need to get everything else by itself on the other side. So I want to get rid of this negative 9 and make it a 0. Well, the only way to do that is to add 9 to both sides. And that way I isolate the x. So if I take a negative 9 and a positive 9, that disappears. I'm left with x on this side, and on this side I have a 12. And then you can always go back and check to make sure you've got it right by plugging the 12 back into the original equation. If I take 12 and I subtract 9, I get 3, so that works. For the next example, here's an example where I have y, or my variable, on two different sides of the equal sign. So I want to get anything that has a y on it on one side and everything else on the other side. So what I'm going to do, I can do anything I want as long as I do it to both sides of the equation. So I'm going to subtract y from both sides. That way I have y minus y. That gives me 0. And then on this side, I'm just left with 6. On the right-hand side, I have a 2y, and I subtract a y. So that leaves me with y. So y is going to be 6. Okay. On example 3, I have 4 times x to give me 24. That one's easy to do in our head. I know that 4 times 6 is 24, but if you can't do that in your head, then all you really got to do, since the 4 and the x are being multiplied together, to break them apart, you want to do the opposite. So you're going to take 4 divided by 4, but whatever I do to one side, I have to do it to the other side. So if I take 4 divided by 4, that gives me 1x on the left. And then on the right, I get 24 divided by 4, which is 6. Okay. In example 4, it's a little bit harder. I have 3z over 4 minus 2 is equal to 10. I want to add 2 to both sides. And I get 3z over 4. The negative 2 and the 2 disappear. They add up to 0, and I don't need to write 0 in there. And then on the right-hand side, I have 10 plus 12, or sorry, 10 plus 2, which gives me 12. Now, to get rid of the 4 in the denominator here, I can multiply both sides by 4 over 1. So I can get rid of the 4, and I'm left with 3z on the left. And then on the right-hand side, I have 48. And then my last step is to figure out what times z would give me 48. And you can do that by dividing both sides by 3. So I get z is 16. Now, example 5, we're kind of leading up to what we're going to be doing when we solve for present value. Notice in this equation here, I have 2 different variables. I have w and I have s. When you have more than one variable in an equation, this is called a literal equation, or sometimes it's called a formula. Okay, and so we use the same rules when we solve literal or formulas. We just got to make sure that we're solving for the right variable. This example says to solve for s, so I want to isolate the s. So what I'm going to do is I'm going to subtract 5 from both sides. On the right-hand side, I'm left with 3s. On the left-hand side, I'm left with 7w minus 5. That doesn't give me 2w because those are unlike terms. I cannot combine them together. That's not a minus 5w, that's just a minus 5. So I got to leave it as 7w minus 5. Then my last step is to divide both sides by 3 so I can isolate s. So my s is going to be 7w minus 5 over 3. Okay, my last example, just as a refresher of solving equations. If I'm trying to solve an equation that has a variable raised to a power, we can use our rules of exponents to solve this. And the rule that we're going to use is the power rule. And if we think back to the beginning of this video, when we talked about exponent rules, and we specifically talked about the power rule, when we raise a power to another power, we multiply the exponents. So what I want to do, I want to make this somehow x to the first power. So I just have x is equal to, and then whatever the answer is. So I got to figure out what would I put here, what would I multiply by in order to change that 4 to a 1. 4 times what would give me 1? So what I'm going to do is I'm going to multiply that exponent of 4 by the reciprocal. So I'm going to raise it to the power of 1/4. But whatever I do to one side, I have to do it to the other side. So I'm going to take 16 and raise it to the power of 1/4. So now when I use the power rule, I have 4 to the power of 1/4, x to the 4th raised to the 1/4. That means I multiply 4 times 1/4. That gives me x to the 1st. And then 16 to the 1/4, if you recall our rules about fractional exponents, the bottom number is the root. The top number is the exponent. So this is the same thing as saying the 4th root of 16 and then raised up to the first power. The 4th root of 16 is 2, and then 2 to the first power is 2. Or if you want, you can just put it in on your calculator as 16 to the power of 1/4. That was a very quick refresher on solving equations. But now we're going to apply that in the last 2 examples. Okay, this example says, suppose you put money into an investment with an interest rate with an APR of 3% and it's compounded monthly, and you leave it there for 18 years. How much would you have to deposit now if you want $100,000 after 18 years. So this might be an example of when you're, as a parent, you're trying to save money for your kid's college fund. You want that $100,000 to be there for college when he turns 18 or when she turns 18. So the idea here is we're working backwards. We need to figure out what the principal should be in order to have the $100,000 later. So when we look at our formula that we used before, principal 1 plus APR over n raised to the power of n times y. We need to figure out what the principal is. So we have to solve this equation for the principal. So what I'm going to do is I'm going to divide, since the principal is being multiplied by this whole big mess right here, I'm going to divide both sides by that big mess. I can do anything I want as long as I do it to both sides of the equation. So now, by dividing both sides of the equation by this big mess right here, I can cross that off. And what I'm left with is that the principal is equal to the accumulated amount divided by 1 plus APR over n raised to the power of ny. So now I can figure out what the principal needs to be if I know what my accumulated value needs to be. So in this problem, it's saying we want our accumulated value to be 100,000. And we're going to divide that by 1 plus, the APR is 0.03. This is going to be compounded monthly, so n is 12. Whoops. And this is going to be for 18 years monthly. So in the exponent, I'm going to put 12 times 18. So I'm going to put all that in the calculator. Now, when you put it in the calculator, you should definitely add in extra parentheses here so that the calculator knows that that whole thing is in the denominator. So, let's see. I have 100,000, and I'm going to divide by 1 plus 0.03 divided by 12. That's going to all be raised to the power of 12 times 18. And then I close my parentheses to show that that's all in the denominator. Now be very careful and pay attention to where your parentheses are, because it's going to change what your answer is if you don't put them in the right place. I'm going to hit enter, and it's going to tell me 5, 8, 3, 1, 4, and 11 cents. So what this is saying is, remember, this was our P. If we want to have $100,000 in 18 years with an APR 3% compounded monthly, we need to deposit right now $58,314.11. And that will give us the $100,000 in the future. Now we can check this on the calculator to make sure that we did this right using the app. So I'm going to go to the app button, and I'm going to use the finance option in the TVM solver. Okay, my big N, that's the number of times it's compounded in total over the 18 years. So it's 12 times for 18 years. So where the big N is, I'm going to do 12 times 18. My interest rate is 3%. The present value is what we're looking for. We're looking for the principal. What do we need to have right now presently if I want to have a certain amount in the future? So I'm going to leave the PV alone. We're not making any payments here. My future value, that's what I want to have in the future, so that's 100,000. And my little n, what it's compounded per year, that's monthly, so this is going to be 12. Then I go up to my present value, because that's what I'm trying to find, and I'm going to hit alpha and enter to solve. And it gives me $58,314.11 when we round it. And that's what I got on the calculator. So we can definitely check to make sure we did our calculations correctly using the TMV solver. Okay, very last question. Suppose you want to accumulate $120,000 for your retirement in 30 years. You have two choices. We have Plan A, which is a single deposit into an account that has annual compounding with an APR of 5%, or we have Plan B, which is a single deposit into an account with a continuous compounding and an APR of 4.8%. How much do you need to deposit in each account in order to reach your goal? And our goal, remember, in the beginning says $120,000. So again, this is a present value problem where we're trying to figure out what do we need to put in for the principal in order to have $120,000 after a specific amount of time under certain circumstances. They give us two options. We have Plan A and we have Plan B. Plan A was compounding annually. If we look back up, if we use the same formula up here, we already solved our formula for P. We want to find the principal. So we have A over 1 plus APR over N to the NY. Our accumulated account, or our accumulated amount that we want to have is 120,000. We're going to divide that by 1 plus, let's see, for Plan A, it says 5% interest, so 0.05 over. And for Plan A, it says it's annual compounding, so that's once a year. So I'm going to put 1 under there for my little n. And then we're doing this for 30 years, so 1 times 30 here. Okay. When we put that in the calculator, we should get $27,765.29. So this is what we need for Plan A to invest right now in order to get $120,000 to retire in 30 years. Okay, for Plan B says it's a single deposit into an account that has continuous compounding. So that's going to be this formula. Okay, and that's going to be an APR of 4.8%. Okay, so for this formula, we haven't solved this one for P yet. I want to get P by itself, which means I want to divide both sides of the equation by e to the APR times y. So I'm going to divide both sides by e to the power of APR times y. So my principal is going to be my accumulated amount over e to the power of APR times y. So my P I'm going to get by finding, whoops, $120,000 divided by E, and it says for Plan B, for the continuous compounding, the APR is 4.8%, so I'm going to raise it to the power of 0.048, and this is for 30 years, so times 30. So in the calculator, I'm going to take 120,000, divide it by, and then to access my E, I have to look above my ln button, so I have to use the second button, second ln, And then I'm going to raise it to the power of 0.048 times 30. Close my parentheses. So the principal for Plan B would have to be $28,431.33. So this is how much you would need to get started with Plan B. So if I were to make a decision based on finances only, I would definitely choose Plan A because you would need less money to get started, but still have $120,000 at the end of the 30 years. Now, we can't check Plan B on the calculator using the time value money option because that app doesn't use continuous compounding, but we can check Plan A. So I'm going to go to Apps, choose Finance. I'm going to go to TVM Solver. Okay, now, once a year for 30 years means my big N is going to be 30. My interest rate for Plan A is 5%. Present value is what we're looking for, so I'm going to skip over that right now. We have no payment, so I'm going to leave that as 0. The future value, I want to have $120,000. And this is compounded once a year. It's annual, so I want to make sure I put 1 in for the PY and the CY. Then I want to go up to present value. That's what we're looking for. What do we need to start off with in order to have $120,000 in the future? So I'm going to hit alpha and then enter to access my solve option. And I'm going to get $27,765.29. So I want to stress to you guys that the time value money solver is a great way to check your answer, but I truly am not going to give you credit if I don't see your formula and your values plugged in. I want to make sure that you understand how to use these formulas.